Hi. This is a quick announcement before you start watching that video that we're going to cover that exact same topic in tomorrow's class as well. So you can join our class using the link in the description, and I'll see you in the class. The next topic that we're going to be doing is going to be outcomes. Okay, so what do you mean by outcomes? Outcomes meaning how many different, you could say, like the way, different ways. Outcomes mean ways. Okay, let's say if you have a question that, let's say you have a three-sided spinner that has the number 1, 2, 3, okay, and another spinner that has 4, 5, 6. If I spin both, what are the total possible outcomes I can get? Okay, so we have one spinner. Let's say I make a spinner here. Okay, we have a spinner here, 1, 2, 3. Another spinner here where we have 4, 5, and 6. Okay, 4, 5, 6. For this, let's first make our box. Now look, we have 1, 2, 3, 4, 5, 6. Now one outcome we can get is that we get 1 on this spinner and 4 on the other spinner. That's going to give us 5. Let's write that with a different pen. So I get 5. That would be, if I get 2 on that spinner, then I get 4. That would be 6. And then I get 4 and I get 3. That's 7. Same for all of them. 1 and 5 I get 6. 2 and 5 I get 7. 3 and 5 I get 8. 1 and 6 I get 7. 2 and 6 I get 8. 3 and 6 I get 9. Now these are all my different possible outcomes, but also going to discuss what if the outcomes are too many. Okay, for example, let's say there are 30 people that are going to be sitting on an airplane. What is the different number of combinations they can sit on? So that's a lot. Okay, so how do we get that? So we're going to learn a formula for that. But now if we want to do it from a smaller number of things, like for this thing, like for the 2 spinners, we can do it like this. So what are the total number of possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9. You can say answer is 9. Now the formula that we're learning is formula for too many different outcomes. Okay, it's not a formula, it's basically a rule that is called the product rule. What does that mean? The way it's going to do this, for example, let's say you have 4 dices. Okay, let's say you have 4 dices. Let's make 4 dice here. That's an example. We have 4 dice. Okay, let's mark them. Let's say we have 3, 2 here, 4 here, 6 here. Okay, that's an example. How many different ways are there to, like, how many different numbers combinations can I get? Okay, the question would be how many different number combinations can I get? Now that's a lot. I can get 1 here, 2 here, 2 here, 2 here. I can get 2 here, 2 here, 2 here, 2. I can get 2 here, 3 here, 4 here, 6 here. So there's too many different outcomes. I cannot list them all. The answer would be, how many outcomes can I get from the first one? 6. How many can I get from the second one? 6. From the third one? 6. Last one? 6. That's what product rule is. You take the total number of different outcomes for one of the, let's say dice, and then multiply them by the other possible outcome as well. So I can get 6 from here, 6 from here, 6 from here, 6 from here. Okay, So that means I get 6 times 6 times 6 times 6. That's going to give me 1296 different outcomes in total. So this is what I use if I want to do, if I want to get different outcomes for a large number of combinations like this. Okay. Next, you might think that every time I have a fair chance of getting something, for example, I have an equally likely chance to get any one number from a six-sided dice, which is 1 by 6, meaning that, let's say if I roll a dice, the chance of me getting a 1 are 1 by 6, the chance of me getting a 2 are 1 by 6, the chance of me getting a 3 is 1 by 6. So for all of them it's 1 by 6 because it's equally likely for all of them. Next, if I have a biased dice, now what is the meaning of biased dice? A biased dice means that you could say there is more chance of me getting a particular number than another one. Okay, so let's say I have, let's take an example to understand this. Okay, let's say if I have a question here, a spinner was spun 100 times, and these are our scores, and I'm going to explain what frequency is, but let me first pick this up. A six-sided spinner is a more accurate term here. A six-sided spinner. Okay, so I can get 6 different scores here. Okay, so I can get score 1, score 2, score 3, score 4, score 5, and score 6. What is frequency? Frequency is the number of times I got that number. Okay, let me write that here. Number of times I got that number. Okay, so I got 1 3 times, 2 14 times, 3 41 times, 4 20 times, and so on. Now the formula to find the probability in this case would be, let's write it here. Formula would be the relative frequency. I'm going to explain what relative frequency is equal to the frequency divided by total number of times you tried the experiment. Okay, now you can use the relative frequency as an estimate of the probability. Okay, I'm going to explain what that means as well. You can use as an estimate of the probability. Now, one thing to keep in mind here, that this will not give you the exact probability, but the more times you do this, the more times you do the experiment, because this time you did 100 times, the more you do it, the more closer you get to the probability, but it's not going to give you the exact probability. Okay, so that's why we use the formula for relative frequency, because that gives us an estimate and we can use that as our probability. Okay, now let's see. First, we can find the relative frequency, okay, one by one. So the relative frequency for this would be the frequency, that is 3, divided by total number of times I got tried the experiment, that was 100. Okay, so frequency for, sorry, relative frequency for 1, that's going to give me frequency, that is 3 divided by 100, that's going to give me 0.03, not 0.3. Then you're going to have relative frequency 2. Frequency is 14 divided by total number of times you did the experiment, that was 100, you got 0.14. Relative frequency of 3 would be 41 divided by 100, that's going to give you 0.41, and this is the estimate of the probability. Okay, and you can use this as your answer for the estimate of probability. Frequency of 4, 20 over 100, that is 0.2. Relative frequency of 5, 18 divided by 100, 0.18. And relative frequency of 6 is 4 divided by 100, or in other words 0.04. So that's how we calculate it if we have to find out from the frequency an estimate of the probability by using the formula for the relative frequency. Next we have a frequency tree. Now to understand this, let's first have a question here. Now we have a question in front of us. Here they say 120 GCSE math students were asked if they would go on to do A-level maths. 45 of them said that they would go. 30 of the students who said that they would go actually did go, and 9 of the students who said that they would not go, they actually did go. So the question would be, draw a frequency tree. Now what does that mean? I'm going to explain. First, you want to consider this display the information that they gave you on a tree-like structure. For example, 120 students. Okay, now we have two ways that we can go about this, and I'm going to explain what that means. The question that they were asked was, would you take A-level maths? A-level maths. Okay, then there are people who said yes, the people who said no, right? Who said yes? 45 of them said that they would go on to A-level maths. 45. So how much is the remaining one? 120 minus 45. That's going to be 5, 60, 75. So 75 said that they would not go. Now 30 of the students who said that they would actually did. So who said they didn't. Okay, who did not go? Did go and didn't go. Who will go? 30. So how much is this? 45 minus 30, that is 15. Then here, who did go and didn't go? They said 9 of the students who said that they wouldn't do actually did do. So 9 here, 75 minus 9, we get 66. So 66 didn't go. This is our frequency tree. We just displayed the information that they gave us on a frequency, you can say a tree-like structure, by just asking questions. Okay, what did you take A-level maths? Yes. Okay, did you go? Yes. Okay, did you take A-level maths? Yes. Did you go? No. Did you take A-level maths? No. Would you take A-level maths? No. Did you go? Yes. And then somebody didn't go as well. Now we have another concept that we have to do, that is called expected frequency. We've done the expected probability, but how do we find the expected frequency if we have to? Now, first of all, you need to know, let's have a question to understand the part exactly. This is the question. It says, a game involves throwing a fair six-sided dice. The player wins if they score either a 5 or a 6. If one person plays the game 180 times, estimate the number of times they will win. So they're not asking the probability, they're asking the expected number of times that they will win. Okay? Now, the answer would be, we have formula. Not just a simple answer, we have a formula that we want to learn. That is, estimated frequency is equal to our probability times number of times you played the game. Number of times we played in this case, okay, obviously. Now, we want to find the probability. What's the probability if I win? The probability is if I get a 5 or a 6 out of a 6-sided dice. So if I get a 5 or 6, so I have 2 over 6. Probability would be, let me write it here, would be 2 divided by 6. I have 2 chances out of 6 to get the answer, and that would simplify into 1 over 3. 2 times 1 and then 2 times 3. Then number of times I played, that was 180. That's the amount that we played. Okay, that is 180. Okay, so estimated frequency would be 1 by 3 multiplied by 180 That's going to be 180 divided by 3. 3 times 1, 3 times 60, and your estimated frequency, so your expected or estimated frequency is this. If you watched the video till the end and you still have some questions about the topic, we're going to cover that exact same topic in tomorrow's class, and you can join that class by joining the link in the description. Okay, I'm going to see you there.